Welcome everybody to the text mining session. In the interest of giving our speakers the maximum amount of time as possible, I'm going to jump right in. Our first speaker is Julia Silge, and she'll be talking about text mining the tidy way.
Thank you. Thank you very much. So my name is Julia Silge, and I'm a data scientist at Stack Overflow, and I am going to be talking about text mining. I'm going to be talking about text mining from a particular perspective, from approaching it with a particular set of principles, and that is with approaching text mining using tidy data principles. And what I am going to be doing here today is to try to make the argument that using tidy data principles can make text mining easier. Easier in the sense of easier to integrate into workflows that are already well understood and well documented, and thus more effective. This work is based on a package called tidytext. So tidytext is a package that I'm one of the authors on, along with my collaborator, David Robinson, who is around here somewhere at useR. So tidytext is available on CRAN, and it's here on GitHub. And what tidytext aims to do is to provide functions and supporting data sets so that you can take text data that you want to analyze, and you can analyze that text data using the universe of packages and tools built for handling tidy data, such as dplyr, tidyr, broom, and ggplot2 for visualization. So tidytext provides a link between the text data, the raw text data that you have, and the tidyverse suite of tools that is out there. So when we talk about, if you've been around R for a while, you probably have heard people talk about tidy data a little bit. So what do we mean when we talk about tidy data structure when it comes to text? So let's look at a little snippet of a poem by Emily Dickinson, and let's talk about what we mean by a tidy text format in the context of the tidytext package. So here we have the first 4 lines from one of Emily Dickinson's poems, and we're just assigning it to a character vector. A character vector is a way that we can represent text in R, or it'd be a string would be a way to think about it in any programming language. We can load the dplyr package, and we can put this into a data frame. Let's add another column that keeps track of which line each one of these is on. So we now have it in a data frame, but this is not yet a tidy data frame. A core underlying principle of what we mean by tidy data is that you have one observation per row. You have one column for every variable that you're observing and one observation per row. Within text, the observation that we're making, we usually talk about it in terms of a token. So the token is a unit of text that you're interested in talking about. Often, the token, the unit of text you're interested in, is the single word. It could be something else, like an n-gram or a sentence, or something that you extract via a regex pattern, but often it's a single word. So let's load the tidytext package, and let's use the function unnest tokens to convert this non-tidy data frame into a tidy data frame. So notice what's happening here. Instead of reading the poem across, we're starting to read the poem down, because each thing that we're interested in is going to be on its own row. We're going to have one observation per row, one token per row, one word per row. Notice a couple things about what happened here. The other columns that we had are still around. Depending on the kind of observational question that you want to answer, you may be annotating the text with many kinds of columns, and those are all still going to be around after unnest tokens. And we stripped out punctuation and converted words to lowercase, and these are often useful things for moving forward with text analysis. Okay, so that was a little tiny example using a little snippet of Emily Dickinson. Let's go through and do a larger chunk of text so we can show what that looks like. Let's take the 6 published completed novels of Jane Austen, and let's tidy them. So you can access the 6 completed published novels of Jane Austen in R from the Jane Austen R package. And let's set up a data frame that is going to look like this. So there's a text column that contains the actual text content of the novels. Then some other columns that annotate them. So book tells you which of the 6 books that content comes from. And then line number is like the line as if you're reading the book. Chapter, we use a regex pattern to say which chapter are we on. So this is a data frame, but it's not yet a tidy data frame. So let's use unnest tokens to transform this from a non-tidy data frame to tidy data frame. Notice that before we had this many rows, and now we have this many rows. So we've made a long, skinny data frame from our wider data frame. So congratulations, we did it. We tidied our text. So wonderful, right? Like, why am I standing up here talking about this? Why is this approach that you might be interested in? The reason why using tidy data principles for text analysis is an interesting and powerful approach is because there are many text mining tasks that becomes easy to reason about using tidyverse tools. For example, often we want to use stop words, remove stop words. Stop words are words in text mining that are not interesting because they're so common. In English, these are words like the, and of. So we often want to remove these kinds of words from analysis before we move forward. So we can do this when our data is in a tidy data format using dplyr's anti-join. dplyr's anti-join will remove stop words. If we do that with our tidy Jane Austen data, after that we can ask the question, what are the most common words in Jane Austen's novels? And we get a result like this. We see words like miss, time, dear, lady, sir. We see some proper names like Fanny, Emma, and Elizabeth. So we were able to get to this with just very few operations from dplyr because we have our data in a tidy data structure. This is an example of the kind of analysis we do by looking at just counting, basically, looking at term frequency. And another quick example I want to look up is this one. This is looking at pop lyrics, songs from pop lyrics, and asking the question, which states are mentioned most often? So this is a project I originally did on my blog that was then picked up by the Washington Post, which was really cool. So if we look at this, we see that the states that are mentioned most often in pop lyrics, just by number, are states like California. And as you, I'm sure, probably can imagine, the U.S. states, the New York is actually referencing New York City. But perhaps you think, well, actually, California is a very large state with many people in it. So maybe what we're actually interested in is how many states are mentioned most often relative to their population. And we can make a map like this. So we can get to these kinds of insights by finding which states have a lot of impact relative, like pop culture impact relative to how many people live there. Using tidy data principles because we've converted our data to a tidy form just by doing counting and working on term frequency. Another text mining task that is well suited by using tidy data principles is sentiment analysis. Sentiment analysis looks at the questions of what is the opinion or emotion content of words. It often is done using sentiment lexicons, which are lists of words like these that have been scored in some way, either as positive and negative, or as, say, a joy or a sadness word, or maybe in a numeric fashion from, say, -5 to 5, according to how positive or negative that word is. When your data is in a tidy form, you can implement sentiment analysis using an inner join. So you have your text data that you're interested in, then you have your sentiment lexicon. You can implement an inner join, and that you can implement a sentiment analysis using an inner join. So let's do that here, back with our Jane Austen data. We do the sentiment analysis with the in that first line, and then a few more lines, and we can get to a result like this. So here we can see the narrative arcs of Jane Austen's 6 novels. We see how positive and how negative are Jane Austen's novels as we go through the books. The sections that have the extended sections of positive and negative sentiment correspond to events that we as human readers understand as good and bad things that are happening here. So, for example, if you look at the Pride and Prejudice part of that plot there, that section near the middle of Pride and Prejudice that has all that negative sentiment, that's where Mr. Darcy proposes for the first time so badly, and Elizabeth is so offended and angry. And that section, about 3/4 of the way through, that is also negative again a lot. That's where Lydia elopes with Mr. Wickham, and it's such a terrible scandal. So we are able to get to this kind of insight where we see narrative arcs through the structure of these novels because we embrace tidy data principles and can implement sentiment analysis in that way. I'm going to fly through these. I want to talk about how can we, in a programmatic way, talk about what a document is about. Term frequency measures how often a word is used in a document. And inverse document frequency is a weight. It's a weight that works like this. It's the natural log of a ratio of the number of documents divided by the number of documents that contain some term. So let's say we have a collection of documents and they all contain some word. That ratio is 1, and the natural log of 1 is 0, and so that word gets weighted down. So we don't have to worry. We're going to not look at that word. If only one of the documents in our collection contains that ratio will be bigger, and we'll take the log of that number, and that will go up. So we'll have a higher weight for that number. If you multiply TF times IDF, you get something called TF IDF, and it is a statistic that tries to find words that are important to a document within a collection of documents. The idea is it's going to find words that are common, but not too common. So let's see how this works out. We can calculate term frequency. I'm just going to go through that really fast. So here, the tidy text package contains an implementation of calculating TF-IDF using tidy data principles. So here you see TF is the term frequency, and then notice IDF there. Notice that it's 0. That's because all 6 of Jane Austen's novels contain the word the, to, and so forth. Instead, we can take this data frame and we can arrange it so that we see the words with high TF-IDF. These are the highest TF-IDF words in Jane Austen's novels. If you're familiar with Jane Austen's novels, you know who these people and places are. Even if you're not familiar with Jane Austen's novels, you can see that these are proper nouns. These are the names of people and places here. So what this is telling us is that Jane Austen used consistent language through all of her novels, and what is most distinctive when comparing one novel to another is the people and places. That's what TF-IDF does. That's what it measures. It's not just something that you can apply to several hundred-year-old narrative text, though. You can also apply TF-IDF to many other kinds of text. I worked on the NASA Datanauts program, and one thing that I did was look at the TF-IDF, measure TF-IDF for words in description files of metadata from their data sets there. And you can get a result like this. So this looks at TF-IDF for description files here, and we see that, again, we're able to gain insight into what is the content of the description fields for the description fields of this NASA metadata using this powerful technique that can be applied to many different kinds of data. All right, so before I wrap up, I want to talk about 2 kinds of extensions that we can make of taking this approach of using tidy data principles for text. One is looking at n-grams, networks, and negation. So we've mostly been talking about looking at just things at the word level, but there are many different kinds of units of text that you might be interested in. N-grams talks about looking at multiple combinations of words, like 2 words at a time, or 3 words at a time. If you look at n-grams, you can look at networks of words and how words are connected together. One way that I recently did this was by looking at n-grams that have a combination of the pronouns she and he, and then whatever word comes after this. This allows us to get at how does the text treat gender? How does the text treat gender? So this is, again, just looking at Jane Austen's novels. So in Jane Austen's novels, the words that have a higher likelihood of coming after she are words like remembered, read, and felt, whereas words that have a high likelihood of coming after he are words like stop, take, and reply. So we're able to get at how does Jane Austen portray gender by looking at n-grams here. This is just one example of the power of extending these kinds of techniques. The last thing that I want to talk about in the extension here is tidying and casting. Using tidy data principles is very powerful, but it's not necessary that you take text data in a tidy format at all stages of an analysis. You can have a workflow where you do something like read in your data, convert it to a tidy form, pre-process. After you pre-process, do exploratory analysis using tidy data principles. Then you can cast cast is something like a document term matrix. And then once your data is in a document term matrix, you can do modeling. You can do something like some machine learning method like topic modeling. And then the tidy text package has support for taking the output of statistical modeling procedures like topic modeling and then tidying the output of that so that you can then deal with the output of your modeling procedure using, again, dplyr, ggplot2, and you're able to you can deal with it in that way. Also, we have support for other text mining packages like Quantita that Ken is going to talk about later. You can tidy and cast back and forth between these different things. So here's a quick example of an example of topic modeling. This is Stack Overflow topics. This is topic modeling of Stack Overflow questions. This is a blog post. This is going to be out tomorrow, so that's a very interesting thing. And I'll just wrap up by putting this up there. So these approaches are available now in a book. So my collaborator David Robinson and I have been working on a book. It's called Text Mining with R: A Tidy Approach. The book is available in its entirety at tidytextmining.com. And actually, as of this week, the actual book is available. It's released this week, so you can buy an actual physical copy at places that will sell you books. So that is that is available now. So we're really excited to see that out in the world for people to be able to see. So what this book provides is the philosophy and resources for getting started with applying tidy data principles to your text mining problems. So thanks. I hear there's time for one question. Yes. So our questioner asked, how is the efficiency of text mining using this approach compared to other things? So someone who, I'm going to forget his name, which is unfortunate of me, but someone who has recently written a text mining package that is all implemented in C, recently did some benchmarking, and I'm sad to say that TM is extremely slow. So TM is really, really slow. Things like Quantita and tidy text are much more performant than TM. The person who I feel really bad that I cannot remember his name, he's written this alternative text mining package in C was even more performant. It was very Patrick Perry, who has written a text mining package in C, was even more performant. I think catch me afterwards if you have another question. Thanks.